Hello and welcome to College Physics 1, Lecture 1, Mathematics Review. Before we begin this series of lectures, I just wanted to point something out that this is a series of lectures intended for my students in my class, but I have made these videos publicly available. So for those of you that might be here from a public viewing on YouTube, first of all, understand that you might see college physics and university physics. The difference between the two is the math that they're based upon. College physics is an algebra-based physics, while as university physics is mostly a calculus-based course. So, being college physics, we are using algebra in this case. Second point of note is that because this is for my students personally, you might not find exactly all the material you need or you're looking for if you've come publicly to see these videos. So please understand that might be the case. So with that said, let's go ahead and jump right in. A study of physics at this level in this course requires some basic math skills. The relevant math topics are summarized in these first two lectures that we'll have. In the first lecture here, we're going to cover exponents, fractions, and solving equations. It is strongly recommended that you review the material in these lectures and become comfortable with it as quickly as possible, so that during your physics course you can focus primarily on the physics concepts and procedures that are introduced without having to become too distracted by the unfamiliarity with the math that is being used. So I like to go through a math review before we begin. So let's go ahead then and jump straight into the material. It's going to start out pretty basic. I think most of us will know what an exponent is, but still it's good to cover. So, anytime you see a value with a superscript, in other words a smaller number on the top right, such as the standard form x raised to the m, the superscript m is called an exponent, and the base number x is said to be raised to the mth power. So, in the case of the example on the right, we would say the base number 4 is raised to the third power, because the exponent is a 3. The exponent itself defines how many times you're going to multiply the base number by itself. So again, using the example on the right, an exponent of 3 indicates that we're going to multiply 4 by itself 3 times. In other words, 4 times 4 times 4. Also note that you can have an exponent that is a fraction. So the standard form here being x raised to the 1 over m. The denominator, in other words the m in this case, is the root. For example, the exponent of 1/2, so if we had to say x raised to the 1/2, that is the square root of x. Now, you could have a fraction that's 1/3 or 1/4 or what have you. For our purposes, we're only going to end up dealing with square roots, so we're not going to talk about cube roots or anything like that. So just know that fractional exponents are roots. Now, exponents will obey several rules in mathematics. So what I mean by this is, we have to ask, okay, well, what's going to happen to exponents as we multiply two values or add two values together? So let's go through some of these rules. We'll begin with the product rule, which means multiplication in mathematics. So let's say we have some base number x raised to the mth power times x raised to the nth power. The product rule for exponents states that if you multiply two values with exponents, you take the base number and raise it to the sum of those two exponents. In other words, x raised to the m plus n. So, as a general example, let's say you have 3 raised to the third power times 3 raised to the second power. You keep your base number 3 and then raise it to the sum of the exponents, which is 3 plus 2. 3 plus 2, hopefully we can do that, is 5. So that gives us 3 raised to the 5th power, or 243. Next up is a very similar situation, but this time instead of multiplying our two values, we're going to divide. hence the quotient rule. So this is a situation in which we have x to the m divided by x to the n. In this case, instead of adding exponents, we subtract them. So you'll have your base number x raised to the m minus n. So for our example here, let's just go ahead and use these same numbers. 3 to the third power divided by 3 to the second power. We keep our base number 3, raise it to the difference of the two exponents, so 3 minus 2, which gives us 1. An exponent of 1 is basically meaningless. You could just get rid of it and it wouldn't change anything. That's just 3. Next up is what we call the first power rule. So this is when you take a number raised to an exponent and then raise that to another exponent. So we could say x raised to the mth power raised to the nth power. In this case, you just multiply the exponent straight across, so we have x to the m times n. So let's say we have 2 raised to the second power, then raised to the third power. That gives us 2 raised to the sixth power, or 64. Okay, there are a few more. I will say that there's no technical name or detailed name for each of these, so I kind of made up my own. So the next one we'll call the distributive rule. So I call it this because this is when you have 2 different base numbers that are then raised to an exponent. In such a case, you distribute that exponent to everything inside. So in this case, you have x to the m times y to the m. The m is distributed to both base numbers. This also works if you have values being divided and then raised to the mth power. Again, the m exponent gets distributed to both. Even if you have 100 different terms inside of this parenthesis, which, hopefully that never is a thing you experience, but even if you have 100 things in here, every single one of them will be raised to the mth power in this situation. Next up is the negative exponent rule. Oh, sorry, I forgot my example. So if we have 3 times 2 raised to the 4th power, that's the same as saying 3 to the 4th power times 2 to the 4th power. Then you can kind of just solve from here. That gives you 81 times 16, or 1,296. Our 5th rule is the negative exponent rule. This is more so just a statement than it is really a mathematical operation. But exponents can also be negative. Anytime you have a negative exponent, that is indicating that your base number is in the denominator of a fraction. So this is the same as saying 1 over x to the m. This one tends to stump students every once in a while when it comes up in the middle of math problems, so be careful with this one. So, as an example, 2 raised to the negative 1 power, it looks kind of weird, so let's rearrange it and say that's 1 over 2 to the first power. Well, remember, the first power is basically nothing, so it's just 1 over 2, which is 1/2. So it's 0.5 if you move it into decimal form. The last one we'll look at is one we already covered a few minutes ago. This is the roots rule. So whenever you have an exponent that is a fraction, remember that is a root. And in our purpose for our course, again, we're only going to deal with square roots. So that would be a number raised to the 1/2 power. So for example, 4 raised to the 1/2 power, that's the same as saying the square root of 4, which is 2. Okay, so that's the first of our 3 topics for this first lecture. Next up, we're just going to take a look at fractions. We're not going to do any examples with these. We're not going to do anything detailed. All we're going to do is glance over the rules for dealing with fractions in mathematical operations. So we'll start with the simplest one, multiplication. So we're going to ask, what happens if you have 2 fractions and you multiply them? Well, my simplest way of saying it is you multiply straight across the fractions. So what does that mean? Well, for example, let's say we have a over b times the fraction c over d. A longer version of what to do states that you multiply the numerator values together, separately multiply the denominator values together, and then combine them. But for a shorter way of saying it, I just say multiply straight across. So a times c over b times d. That's it. That's the easiest of our rules for fractions. Division tends to stump students a little bit more. The shortest way of saying this rule is to multiply by the reciprocal of the denominator. That's a little technical, so here's a straighter definition. You can invert the fraction in the denominator, then multiply it by the fraction in the numerator. So let's take a look at this. Let's say we have the fraction a over b divided by the fraction c over d. So what we're going to do, let's follow this in parts, invert the fraction in the denominator. What that means is flip it over. So let's say now it's d over c. You then take that and multiply it by the fraction in the numerator. Okay, so flip this, it's d over c, and now we're going to multiply it by the value in the numerator, which was a over b. So this is what we say as multiplying by the reciprocal of the denominator. Now, it's just the multiplication rule. Multiply straight across, you end up with AD over BC. Okay, so for the students in my course, you will encounter this every once in a while in some math problems down the road. So make sure you're comfortable with this one moving forward. The next one is arguably one of the more challenging ones, or at least the more involved. The good news is I don't think we use it much, if at all, in our course, but I still want to go over it since we're already here. This is when you add or subtract fractions. In general, the shortest way of saying this one is you need to find a common denominator. Stating this in full, you multiply each fraction by a factor that equals 1 so that they have the same denominator. So let's say we start with a over b plus or minus c over d. And note I'm saying plus or minus because this rule works for both addition and subtraction. So plus or minus just means whichever one you're dealing with. So to do this, you need to find a common denominator. So on the left, we have a fraction being divided by just b. On the right, we have one divided by just d. These are not common denominators. They're not the same. So our goal is to set it up so that they do have the same denominator. In other words, we need to have a d on this left-hand side, and we need a b over here on the right-hand side. So to do that, we're going to multiply each side by 1. Now, this might look a little sloppy. I'll probably get rid of this in a second, but we're going to try to multiply both sides by 1. To do that, notice that we need a d value in the denominator on the left side. So why don't I multiply by d over d? D over d is just 1, so I'm not changing the value here at all. But I am allowing a d to be in the denominator. Well, do the same kind of thing on this side. This is going to look sloppy again, just kind of ignore that. We need to get a b over here. So why don't I multiply by b over b, which is, again, just 1, so I'm not changing the value, but now it gives me a b in the denominator. So what I've done is just written as the next part of this equation. So that's what I did to get to the second step. Okay, so here we have that. So d over d times a over b plus or minus c over d times b over b. Now, again, we can just use our multiplication rule and multiply straight across. This will give us, if you rearrange it alphabetically, AD over BD plus or minus BC over BD. Notice they're both divided by BD, so we have now found a common denominator. So we can have it as a single denominator across everything. So we have just BD on the bottom, and then AD plus CB on the top. That is, in very quick terms, how you find your common denominator to simplify the addition or subtraction of fractions. To close out this lecture, I mean, it's still only about halfway over, but our last of the 3 concepts we're going to cover in this one is solving equations. So oftentimes, one of the symbols or variables that you find in one of your equations will be considered unknown. In other words, you don't know what the value is, so you're going to have to solve the equation to get it. And so, one thing to keep in mind is anytime you perform a mathematical operation on one side of the equation, you have to do it to the other side of the equation as well for the equation to remain valid. In other words, if you multiply one side by 5, the other side has to also be multiplied by 5, otherwise it's not equal anymore. So what we're going to do is just go through a series of random examples. So for example here, let's solve a bunch of equations for x. We're going to start with a really simple one, as you can see, and I think we're going to do 6 of them, each one maybe adding in an extra step perhaps. So let's go ahead and try to solve some of these more simple equations. So equation 1 is y is equal to x over 5. Our goal here is to solve for x. To do this, there's really only one step. We need to get x on its own, which means we have to get rid of this 5. Since the 5 is in the denominator, to get rid of it, we're going to multiply both sides by 5. Right? So multiply both sides by 5 to get rid of it, and we should get our answer immediately. So let me write this out here. I'll use an arrow to indicate we're doing something new. So x, if we multiply both sides by 5, will be equal to 5y. And that's it. Can't really have a simpler equation to solve. Note, if you're my student, I do always ask that you show work. In this case, you don't have to do what I did initially and write a 5 times y equals x over 5 times 5. If anything, I actually think that clutters your work up and makes it a little messier, so don't feel like you need to do that if you don't want to. Also recognize there's no numbers. We're just rearranging the equations for x. The next one. We have ax minus y equals 2y. Okay, so one of the things you're going to start to recognize is that there are multiple ways to solve an equation, typically. The first thing I would do here is I recognize that there's an x term here with this extra little negative y term. Well, we want to get x on its own. So typically what I'll do in this case is take that extra term, in this case the minus y, and get it to the other side. So let's add y to both sides. That will leave us with ax on the left-hand side equal to 2y plus y on the right-hand side. So again, all I did was add that negative y to the other side. So this is just 3y, right? So 2y plus y is 3y. Okay, so we have ax equal to 3y. So if we want to solve, we have one step remaining. We have to get rid of the a. To get rid of the a, we divide by a. So this leaves us with x is equal to 3y divided by a. And there is our solution. One thing to note for my students is I do ask that you box your answers, especially when we get into longer and more complicated problems. I want to make sure I know what you are telling me is your answer. So make sure you box answers. Just get in the habit of doing that throughout the semester. Okay, several more. Again, trying to up the difficulty a little bit each time. Number 3 is a times the quantity x plus b equal to c. Now, this is one where you definitely have students split on what to do first. I'm going to just choose the shorter of the two options, but I'll tell you what the longer one is. You could take this a and distribute it to both the x and the b. In other words, you can end up with ax plus ab. But we can save ourselves a step and just take that a and divide it straight over to the other side before we even worry about distributing. So let's go with that route. Let's take that a and divide it to the other side. That leaves behind the x plus b on the left and leaves us with c divided by a on the right-hand side. Now there's only one step remaining. Subtract the b to the other side. And so we have x is equal to c divided by a minus b. And now we have x on its own, so that's our solution. Okay, number 4. y divided by x plus a is equal to b. Now this one's a little bit different because we now have our x value in the denominator of a fraction. So before we worry about that, I'm going to do what I did in the second problem and recognize that there's this additional term hanging out here that I want to get to the other side. You don't have to do this first, but I would take the a and subtract it to the other side. So that leaves y divided by x equal to b minus a. Now, this situation here does come up every once in a while in physics, not with this exact equation, but a similar situation, and students again tend to get confused. Because the x is in the denominator, we're going to have to multiply it across to the other side so that it's out of the denominator. Excuse me. So that leaves the y on the left-hand side equal to b minus a times x. Okay, so I multiplied x to the other side. We have one step remaining. X is being multiplied by this quantity b minus a, so let's divide it to the other side. That will give us x is equal to y divided by b minus a. And there is our solution for number 4. Okay, we have 2 more. Number 5, this one's not particularly difficult, but it does introduce something new again, and that is a square root. So we have the equation, the square root of x plus 3, then minus y equal to 0. Once again, we have this little extra term hanging off on the side, so I would first move that over. So that gives us the square root of x plus 3 equal to y. Right, so I just added y to the other side. Now, we have to deal with this square root because the x is underneath it. We can't subtract 3 over yet because it's underneath the root. So we have to deal with that square root. So how do we get rid of it? Well, remember, a square root is the exponent 1/2. To get rid of 1/2, you multiply by 2. In other words, we square this term. So to get rid of a square root, you square it, which means we're going to have to square the right-hand side as well. So this will give us x plus 3 equal to y squared. Okay, square both sides. At this point, the last step should be pretty apparent. We just have to subtract the 3 to the other side. So we have y squared minus 3 as our solution. Oh, I'm getting a little shaky there. Okay, fantastic. So last one, this one will be the most steps we've seen because in this one we have x in 2 different places. The equation says a times the quantity x minus y is equal to b times the quantity x plus y. Now again, there are multiple routes you could take to solve. The first thing that I would do is distribute a into the parentheses and distribute b into the parentheses. So let's go ahead and do that. We're distributing a, so we have ax minus ay. And now we distribute the b, bx plus by. So that gets rid of the parentheses at least. Now notice, we have 2 terms containing x and 2 containing y. Our goal here is to get the x terms on one side of the equation and our y terms on the other. So in this step, all we're going to do is some rearranging. I'm going to take my bx and subtract it to the left-hand side, and take my ay and add it to the right-hand side. This will leave us with ax minus bx equal to ay plus by. To rearrange my hand here a little bit. Ay plus by. Okay, so I've just moved 2 terms. Now you can see that we have all x terms on one side, all y terms on the other. So we're getting there. But we do still have x in 2 places. We need to find a way to combine those x's. Well, notice x is being multiplied to both a and b, So why don't we factor that value out? In other words, factor out x so that you have x times the quantity a minus b. And you don't have to do this, but let's factor out the y as well, equal to y times a plus b. So now we only have one x and one y. That kind of helps a little bit. We only have one step left. I'll write this down in the bottom here. We need x on its own. It's being multiplied by the quantity a minus b. So let's divide that to the other side. X is equal to y times a plus b and divided by a minus b. So this would work as your solution. We have got x on its own in terms of y. Now again, you might have a different brain in terms of how you operate some of these equations, so I might have done something differently than you might have seen when you were first looking at each example. Again, that doesn't mean you're wrong, it just means you're looking at it in a different way. As long as you get an identical answer, you're fine. You just figured out a different way to solve the problem. Okay, we're going to look at one more thing here. Oh, and by the way, notice that I didn't plug any numbers into these. All I did was rearrange for x. So I didn't plug any numbers in for a or b. This is very common in physics. So it is widely believed that it's easier to work physics problems by substituting numbers in at the very beginning of the problem. A lot of my students will do that. They'll plug their numbers in right away in the beginning. However, expert physics problem solvers will typically solve the physics problem using the variables, so for example a, b, y, what have you, and then substitute the numbers in only as a final step. So once we have these boxed answers, then you plug the numbers in. Because this approach is not only generally faster and easier, but it also reduces the number of mistakes you'll make and results in a better and more general understanding of the physics in the problem. It might take a little bit of practice to get used to doing that, but it has some very important benefits. So I encourage my students or anyone watching to first rearrange your equation and then plug your numbers in. It took me a while to get used to doing that, but I will never go back. It makes things way better. So please get used to doing that. Okay, so to conclude this lecture, we're going to look at one more type of equation, and it's a very specific one, and that is quadratic equations. We only encounter these, I think, twice in my particular physics class, but it's good to get a primer on it now. So a quadratic equation is any equation of the form ax squared plus bx plus c. So the key here is it has a term that's squared, one that's to the first power, and then one that's to the 0 power, or there's no variable x in the third term. The letters a, b, and c are just constants. So there are a couple ways you can sometimes solve these. You could try to use like a FOIL method, but in our purpose, we're going to use the quadratic formula to solve. This is a pretty commonly remembered equation, even though it's pretty hideous looking. The quadratic formula says your value x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now, notice there's a plus or minus symbol. That means that you're going to end up with two solutions, one when you use a plus sign and one when you use a minus sign. In the context of our physics problems that we deal with in the course, you'll be able to determine, if you understand the problem, which of the two values is the real solution. We'll talk more about that when we get there. So, how do you solve one of these? Let's just go through the steps and show an example. First step, get your equation into the form of ax squared plus bx plus c. That sounds weird because, if it's a quadratic equation, that should be its form, right? Well, yes, but it might not always look exactly like that. As an example, it could be, say, 2x squared equals 3x plus 5. It doesn't necessarily look exactly like the equation above, so let's rearrange it so that it does. Take the two terms on the right-hand side and subtract them over. We have 2x squared minus 3x minus 5 equal to 0. So now, if you compare it to what's above, it's very clearly in the same form. This is indeed a quadratic equation. Our next goal is to identify the values of a, b, and c. So in the context here, a is whatever's out in front of your x squared term. B is whatever is out in front of your x term. And c is whatever number is out on its own. So in the context of this example, a is 2, b is negative 3, and c is negative 5. Note, the negatives do matter. Once you know your a, b, c's, you substitute them into the quadratic formula. This is a tedious process, but you just kind of have to pray to the calculator gods that you do it right. So this is what the equation looks like with our numbers plugged in. And hopefully if we solve it correctly using both a plus and a minus, you can then solve to get negative 1 and 2.5. Okay, so that is it for our very first lecture of Physics 1. This is just a primer, so this really isn't even the physics material yet. In our next lecture, we're going to finish our math review by talking about direct and indirect relationships, the equation of a line, plane geometry, areas and volumes, and then conclude with the most important of all those, trigonometric functions, sine, cosine, and tangent. Until then, thanks for watching and have a great day.